integer arrays and integer k, and we have to return the k's largest number in this array. And for example, given the array of 3, 2, 1, 5, 6, 4, and k is 2, you return 5, which is a k's largest number of this array, because 6 is a 5, 6, because you can say 6 is first large and 5 is the second large. So it's a very classic bucket sort based approach inspired by the idea of counting sort. Counting sort is a linear sort algorithm which is applicable when value to be sorted within the definite range. For example, they're distributed in a relatively small interval. Let's analyze the solution step by step. So here is the solution. Let's analyze step by step. For example, you can see the problem requires us to find the k's largest element in an array. Naturally, this problem can be solved by sorting and directly taking k's element, but the time complexity is generally O log n. Here we hope to more optimal solution. Number 2, we're using bucket sort. In the solution, we notice a feature that the input elements are integers and have a limited range between minimum numbers and maximum numbers. This allows us to use counting sort or equivalent bucket sort. We set up a bucket for each integer within this range to count the number of times the integers appears. Count the number of times integer appears. This time complexity of this process is O(n). Number 3 is counting elements. For each element in the array, we put into a corresponding bucket. Increment the counter for the corresponding bucket. The time complexity of this process is O(n). And finding the nth largest element. Now we have the counts of each element. We just need to start from the largest element and accumulate until the total count reaches k. In this way, we find the k's largest element. The time complexity of this process is O(m), where m is the maximum numbers minus minimum numbers plus 1. The overall complexity of this solution is O(n plus m), which can be considered O(n) where m is close to n. This is significantly improvement compared to the traditional sorting n log n. However, this solution has a disadvantage of requiring additional space to store the buckets. Thus, it has higher space complexity. Define the minimum value, maximum value, and frequency bucket 0 and brackets minus maximum value minus minimum value plus 1, and count the frequency of each number in the input list. Have the numbers and you get the frequency list. Number minus the minimum numbers, number minus minimum numbers plus 1, and accumulated a count for each. This number is each number minus each number inside this numbers array minus the minimum value of this array. Then this is the accumulated count equal to 0 for I in range of 1 to length of frequency bucket plus 1, and you have accumulated a count plus the frequency bucket plus the frequency bucket accumulate a count plus and equal to the frequency bucket length of the frequency bucket minus 1. Yeah, so you want to iterate through from the backward, and if the accumulated sum backward for the because of so frequency bucket is small to large, and you want to iterate through from the backward, and if the accumulated count is greater or equal to k, and return the length of frequency bucket minus 1 plus minimum value. Return the length of frequency bucket minus 1 and plus minimum value.